The last big system we're going to take a look at modeling is the following system. The following is actually going to be rather simple and straightforward in nature. A following system really sets up a relationship between one user and another. One user might be called the follower, the other the followee. You might also call it a leader and a follower. So in this case, if I were to follow Stephen Wilkes would be the leader, I would be the follower. In general, the only big rule around any kind of follow system is that we can only follow another user one time. In addition, usually we cannot follow ourselves. So creating some kind of table to model this relationship should be at least somewhat straightforward. Here's what I think we could possibly do. So we might make a table of followers, and then it can have columns like user ID and follower ID. User ID would be the user who is being followed. So if I tap the follow button for Stephen Wilkes, this might be Stephen Wilkes user ID right here. And then I might also have a follower ID column, and that would be the ID of the person who is doing the following. So this might be my ID right here. Now, in this case, remember, we've named a lot of our foreign key columns after the table that we're essentially referencing. This time around, we've got a reference to some user and a reference to another user. And so we cannot have two columns here with identical names. So in this scenario, we kind of have to think of some original or some column names that kind of make sense in the context of what we're trying to implement. So we could make the follower column just simply user ID, and then the followee, or the person who's doing the following, the follower ID. We could make the user ID follow, or how about leader ID? You can really come up with just about any combination you want, as long as it is something that would immediately make sense to other engineers who are looking at these column names. Now, to actually make sure that we cannot follow ourselves, we might put in a very simple check validation constraint, like the one you see right here. So we might say that the user ID or the leader ID, whatever we end up calling it, cannot be equal to the follower ID. In addition, to make sure that one user can only follow another user exactly one time, we could also put a unique constraint across the concatenated value of leader ID and follower ID. So we could put in something like unique, leader ID, and follower ID. So that means we can never have any row or any two rows with an identical leader ID and follower ID. Well, that's pretty much it for setting up a follower kind of system inside of an application. Really not the worst thing in the world. By making use of this table, we can very easily write a ton of different queries to figure out who has the most followers, who has the least, the usernames of people who are following a particular user, and so on. So let's go back over to dbdiagram.io, or whichever tool you're using, and just put in a very quick definition of what the followers table might look like. All right, so I'm going to flip back over. Oh, where'd it go? There we go. I'm going to go down to the very bottom, and down here I'm going to add in a table of followers. I'll give it an ID. I'm going to give it a created at timestamp. Created at, in this case, would be very useful for figuring out how long someone has been following another person. We could also use it to tell the user, hey, so-and-so just followed you like 5 minutes ago or something like that. This is another scenario where we probably don't need an updated at column, however, because there's really nothing to update here. Once we add in a row, we would never make any updates to it. If someone unfollowed another person, we would just delete the relevant row. So there's really no concept of updating a follow system. Then we might add in, I think we'll go with leader ID and follower ID. I think that makes a lot of sense. You could as well just call this simply user ID and follower ID. Again, it's totally up to you. So I'll do a leader ID. That's going to be an integer, and that will be a reference to users.id. And then we're going to have a follower ID. That's also an integer. Followers, or excuse me, not followers, users.id. There we go. And that's pretty much it. Okay, so I'm going to take a look at our diagram one more time here. And that's pretty much what we're going to end up with. I can zoom out a little bit just to make this a little bit more clear. There we go. So once again, if you want to, you could certainly start to drag these little things around, try to make all the lines line up in a nice, pretty way. Totally up to you. Not strictly necessary. You can always just hover over one of these things, and it's going to tell you how it's related to everything else very easily. You also might try kind of rearranging the different rows in each of the different definitions so that the lines kind of just line up a little bit better. For example, on likes right here, I have post ID as the very last column. If I actually move it up 2 spots, then the post ID row would be just a little bit higher. I'm going to do that really quickly just as a very quick demonstration. So here's table likes. I'm just going to move post ID up 2 lines. And now the lines coming out of likes are just a little bit better organized. They don't have that immediate crossover each other. I could probably do the same thing for maybe user ID on posts as well. Maybe move it a little bit higher or lower. Again, doesn't really matter. If the diagram ends up being a little bit complicated, that's totally fine. It, again, does not mean that you've got a bad design or anything like that. Okay, so I think this looks pretty good. So we're going to take a quick pause right here and decide where to go in the next video.